Hi, Andy. Thank you for joining us.
Thank you for the opportunity.
Andy, it's safe to say that you've had a pretty incredible career. Can you give us a brief rundown of the events that brought you to firefighting and to ultimately establishing Insight Fire Training?
Well, I grew up in a very rural part of America where there was nothing but farms and there was it wasn't even a stoplight in the town I grew up in. So my father worked full time for AT&T and volunteered at a local volunteer fire department. And there was no first responder area or way to provide emergency medical coverage at the time for our town. My dad helped found that when his mother got sick. So when I was a kid, how I learned about all this was he would come home from working and he would get in the car and go to the volunteer fire station. So if I didn't go with him, I didn't get to see him. So as a kid, I was playing on basically while they were in meetings, they had fire trucks in the bay, and I would be jumping from one metal bumper to another, trying not to touch the floor. That was like my first playground. Now I won't let my daughter play on a playground that has rubber mulch and safety stuff, and it's a little bit of a hypocrite there because I played on rusty metal fire trucks as a kid. But I got into that very early, and it was a organization that there was, no one was paid for what they did. The town was funding that, and I saw the value in it and became a junior firefighter when I was a teenager, which was a healthy place to be instead of getting into other things. So as my dad said, I was a good kid until I was 19. Then he thought about taking me out. I had that 1 year where I wasn't so well behaved, but as a junior firefighter, I learned a lot and I got around some good mentors, and then became a certified firefighter at age 16, fought my first fire at 16 and was hooked, if you will. Went, graduated high school and started community college, a local community college. And through my father, I met Chief Alan Brunancini. My dad was big into teaching at the time. He was taking a lot of business concepts and teaching the American Fire Service. And I met Alan Brunancini and offered me a college internship with Phoenix Fire Department. And I got to spend my summer working at the training academy and living at Fire Station 40 as a 19-year-old kid. So I'm forever grateful for the Brunancini family and everything they did for me, because it opened my eyes to a lot of things outside of what I was used to. Went back, finished my community college degree, got hired by my fire department where I work now, Charlotte Fire Department, in 1998. Was started there, got promoted to captain in 2007, was promoted to battalion chief in 2018. And in between there, I got involved with my father in something called Project Kill the Flashover, which is an applied fire science research project, which was another way to hang out with my dad. If you'll notice, everything was just hanging out with my dad. And that's where I fell into thermal imaging, was through that. It was a very small project to help volunteer departments. And my dad and several other smart people like Chief Sean Oak and some other ones started doing this, and people from other countries came in. And I met people from Germany and Sweden, all over, in this little small town. And in 2015, while I was helping do all this, I got hurt. I fell through a floor and ripped my knee in half when we were prepping a house to burn, and almost disabled myself and almost ended my career. And that was when my wife politely informed me that if I was going to play firefighter or thermal imaging trainer, that I had to get insurance and make it legal. Hence, Insight Training was born right there, because that's the whole point of where all this started. Had nothing to do with where I'm at now. It was simply, if you're going to leave this house, you need to protect your family. And when I was hurt, I learned something that I never knew before, which was everyone else who goes into thermal imaging goes to school, except firefighters. And I started that journey, which leads you to your next question, which is where I started. I started going to school and learning, oh my word, what do we not know about thermal imaging? And that's where the rabbit hole begins, with Alice in Wonderland, so to speak. So
Yeah. So please tell us more about Insight Training.
well, I started basically as an emphasis to it because I was hurt, and I started learning that everyone else went to school, and I learned about thermography training, and I learned that industrial training or industrial trainers or thermographers had a minimum of 32 hours of training. And I started digging into this, and I said, why don't I look into this? And everyone I talked to discouraged me going that route. They said, no, it doesn't really apply to the fire service. You don't need that. And I just felt compelled to do it. So I went to school and when I came in, they make you fill a survey. It says, how much do you know about thermal imaging? And I was trained by manufacturers and a lot of smart people at this point, and I felt like I knew a little bit. And I put, I know a little bit about thermal imaging. At the end of the course, they ask you again, what do you feel like you know about thermal imaging? And I put, I feel like a caveman holding a flashlight, because what they were doing in industry far exceeded what we could even imagine in the fire service. So I knew right then and there that I had opened up Pandora's box and I had to keep going. So Insight Training was founded. I got my level 1 thermography certification. I went and got my level 2 thermography certification. I started getting certified in residential things like residential inspection, HVAC inspection, window thermography, a lot of different things that had what people said had nothing to do with firefighting. And I found a bridge between the two. So physics is physics. Infrared science applies. You just had to learn to write, make those concepts experientially relevant. So I wrote an entire curriculum based on industrial concepts that relate to what we do in the fire. And that's where everything began. I started meeting people and traveling and training and teaching, and started with a very basic program. And now we have up to a 32-hour course. It's been peer reviewed by infrared training centers from multiple organizations to manufacturers. And now we have a collegiate curriculum through that's been peer reviewed by thermologists and certified through Western Kentucky University. So from starting from hanging out with my father to falling through a floor to feeling like a caveman holding a flashlight, now Insight Training has trained in all 50 states and over 30 countries. We have helped people, and we help manufacturers now. We do product development and consulting. We do testing on things outside of thermal imaging. We get involved with PPE and flashlights and things that have to do with the fire environment, because we do about 100 live fire events a year. And I have 14 people working for me, all because I fell through a floor and got hurt.
Yeah.
So if you think something happening to you is not meant to be, and you had something bad happen to you and that's the end of you, no, it's not. It's probably just the beginning of your journey. So that's the short version of the last 10 years or so.
And when did you first come across thermal imaging cameras, and what was your first impression?
I didn't see it as a volunteer. We didn't have that until I got hired career, and I got hired in 98. We didn't have them officially till 2002, but I saw them in 2000. So 23 years ago, it was like an old MSA 5000 camera, I believe what we saw. And that's what our department had for ever and ever until 2018. And our department upgraded to, FLIR K65s at the time. So it was a very, rudimentary if you look at it now, but back then it was like, this is innovative. This is amazing. It's black and white TV and it's amazing, compared to like looking at your iPhone now compared to looking at a cell phone from 20 years ago. So it was pretty eye-opening for me, but I wasn't hooked in it until I got involved with my father, and I got involved with people outside of my comfort zone, people from other countries that opened up my learning, and then people who built cameras who showed me what a camera could do, taught me words like emissivity and don't use the spot temperature and things of that nature that firefighters didn't know. So that's my initial exposure. And then when I first got exposed to it through Project Kill the Flashover, a gentleman who used to own ISG, which Scott Safety bought out, showed me something. He said, hey, go in here and tell these people, well, watch over and keep them safe. And I need you to call out, apparent temperatures, because this camera's recording. And I said, well, don't you think I need to know how to use this first? And he gave me like a 15-minute little lesson. And then he pointed it back at the burning building. He said, now, do you feel comfortable ducking and diving under that turbulent black smoke that's exhausting out that door? And I said, honestly, I feel like I should go home and apologize to my wife, because I should be dead. Mm. And it changed my whole paradigm, if you will, for me. So that's where that whole beginning came for me, because I looked at fire one way, and a thermal imaging camera caused me to look at it a different way, a completely different way.
How do the old cameras, like the MSAs, compare to the newer cameras? Are they completely different?
Well, the fundamentals of infrared science are the same, but when you look at how they've changed since the infrared technology was first introduced, if you think to the very first mention of infrared science is the ancient Egyptians putting mud on people and seeing where it dried first, and they would detect that's where the disease was in the body, or they take their hands and rub over someone if they felt a warm spot, that's where the infection was found. Versus Sir William Herschel in the 1800s, when he discovered it and actually considered the area outside of visible light was infrared energy. He didn't even call it infrared then. He called it dark heat. Well, firefighters have said anything over their head they couldn't see that was hot, that was, they call that black fire. So we had this correlation as we moved into this area where all of a sudden military grade equipment, which was infrared stuff, became declassified and into firefighters' hands, from the very first big, bulky Carnes Iris to these giant cameras that look like a black and white TV on a stick, to what we have now, which is much, much lighter weight and higher resolution and better pixel pitch and higher quality as far as image, and faster and able to pick up smaller differences in temperature. So has it changed? Dramatically. Is the science behind it the same? Yes. But what you're seeing is just like a cell phone was a phone. Now a cell phone is a 2 terabyte computer. It's not just a phone. So an infrared camera is not just an infrared camera anymore. It's a thermal imaging camera with software enhancements and application modes and bells and whistles and things that probably may or may not have been intended for the fire service, but now we're starting to look towards different avenues of how that camera can see that environment better. So yeah, it's changed dramatically.
And how do you train new firefighters to use thermal imaging technology effectively?
Well, I don't just train new firefighters. We train everyone. So when we come into a room and we have a group of people, I usually size the room up by asking them, what's one thing you want to learn today? So we begin by learning where they are, but then our training is very simple but intense. We introduce them to, or a reintroduction, if you will, to the word heat. Firefighters were taught, just like I was, and I'm not preaching down to them in any way, shape, or form, because as my father said, you didn't know any better when you started either. We were taught to measure heat by sight, what we see, and what we feel, which is a late sign. What we do is we reintroduce them to it through science, through data, through research, through line of duty death, burn data. We go through all of that and we show them there's much more going on. Like 2/3 of the energy in a fire are transmitted in the infrared spectrum, which you cannot see. And we talk about 3 perspectives of how that heat affects the things that they value: the victim, which they swore to protect; the property, which we swore to try to conserve; and then the firefighters themselves, as far as that energy is hitting them and they don't know it. And then we break that down in the first hour. We don't even talk about a camera. We show them videos and pictures of it. And you see the eyes open about when they feel pain and when they actually experience a burn, and when their gear is actually absorbing all the energy and what occurs and the science behind it. Because a lot of firefighters have never been told that. And some of that's been anecdotal, passed on. Some of it has never been explained. Some of them have never researched it. And a lot of fire departments don't provide thermal imaging training. So we start there, and then we go into types of cameras that are available in the market today. We break down their camera in a very intensive overview, because unfortunately no camera is the same. They all have different application modes and color temperature correlations. And then we spend the remainder of the day, this is just day one, if we do multiple days with them, literally teaching them to interpret what they're seeing. Like if you pick up a map and you're walking the streets of your town, at the bottom of every map is a legend, a key, or a scale. If I'm in another country, like I'm coming to see you, I would have to know what those mean so I could adequately find my way. Well, no one's teaching firefighters what the colors mean, what the symbols mean, what the triangle means, and why does it do that? Why does the camera freeze? And was that normal? Is that not normal? And then end user behaviors, like things like, I should wipe the lens periodically to keep it from fogging up. I shouldn't stand up. How I scan, all of that we break down for them, so that not only do they interpret it properly, but they use it properly. And then we spend the last part of the day telling them how it can hurt them if they're not careful, limitations, contraindications, and how to overcome those. Because some of that I was taught is actually passed on from other people that didn't understand thermography. Like something as simple as a thermal imaging camera can't see through glass. Well, it doesn't see through anything, but context is everything. Otherwise, you wouldn't have window thermographers that inspect windows. And single pane glass is completely different than double pane or triple pane. So that's a full 8-hour day, and we always include some type of live fire demonstration, because I don't believe in doing classroom only. I will do it, but I don't prefer it. They have to have a heat source so that you show them in a classroom, then you show them with some type of small scale model so they can better understand what you're saying. And it's not fully understand, but better understand.
When you started Insight Fire training, did you find there was a resistance to new technology in the industry?
Firefighters are resistant to change in general. I mean, Alan Bernstein, God rest his soul, used to say 2 things firefighters hate: change and the way things are. So we didn't like either one. So, you know, what I found was they weren't just resistant to technology. They just lacked education and understanding, just like I did. So never forget where you came from, number one, right? So I came from the same place, and I consider myself a student. People call me different things, some good, some bad, but people think that I'm an expert in this, and I just tell them I'm a student. I'm continually learning, because the minute I stop learning, then I rest on my laurels, and then someone will take my place, or I'm not helping the student adequately, more importantly. But I found that many firefighters were resistant because a senior respected person that they looked up to told them this and they believed it. Well, people can say what they want about millennials, but if you challenge, you give a millennial something, they'll take out their phone, they'll Google it, they'll look it up, and they'll see if you're wrong. And in today's environment, you need to be able to challenge people and say, please look it up, verify it here. So I think that had a lot to do with it. And it was also a complete lack of focus in their organization. Thermal imaging was not considered important because the way the text was delivered about understanding fire behavior and fire suppression, it was, once again, suppression or fighting fire was more of a visible and a feeling mindset. What do I see and what do I feel? That's how I fight that enemy. That's not adequate in the environment we work in. And once we start to educate them, then you start to see their eyes open and bells and whistles go off in their head, and they go, now I understand. But I think it takes someone doing that in a way that doesn't invalidate them. Don't talk down to them just because they don't know it, because someone hasn't taken the time to do that. Because if someone hadn't taken the time to explain it to me, I wouldn't be sitting here sharing it with you. So that's the way we teach. We don't teach in any way, shape, or form that talks down to you. We're all about building people up, meet them where they're at, and bring them up. And our goal was that we develop what we call intelligently aggressive firefighters. Firefighters have always been aggressive, but we want to give them information to make more informed decisions to do their job better, faster, safer, and smarter.
Has that resistance changed now, surely?
Not fully. I think you still, I mean, I've been a lot of places, and we just trained at FDIC, the largest fire training conference in the world, had over 200 students, and I would say 70% of them did not know the information we were passing along. There were people from Australia, from Canada, from all over, and they were wonderful people, but they haven't had that information either. They weren't resistant because they took the time to take the class, but based on what I heard from some of the students, some of their organizations have that resistance as well. There's a lot of people that say, hey, you shouldn't rely on technology. And I look, as they're telling me that, they're texting on their phone. I'm like, really? Well, let me take your smartphone away from you for 6 weeks and let me see how you behave. Because I think we're resistant to the things we want to be resistant to. We don't, when we find out something benefits us and we learn that benefit and we like that benefit, then we don't want that benefit taken away from us. My mother-in-law refused to get an iPhone until she could no longer get text messages from her grandbabies because her phone was so antiquated that the messages weren't coming through. So we bought her an iPhone. We took her to a class. They taught her how to use an iPhone. And guess who you cannot get that iPhone away from now? You cannot get that iPhone away from my mother-in-law. Now, she refused to have one. But once you taught her how to use it and how valuable it was and that she could FaceTime her grandchildren, good luck getting that phone away from her. And I think in the same breath, when you teach a firefighter something they're resistant to, someone taught me this a long time ago. Don't answer the question, answer the questioner, the person behind it. There's a reason they're resistant. It's not because they're obstinate and angry and bitter and cynical. Something happened. They have a reason. They have a question, a lack of understanding. Some people don't like to, be told they don't know something. Ask my wife. I can be right or I can be happy. I don't know anything. Okay. I'm constantly learning. So getting firefighters to open up first occurs by the instructor opening up themselves and not being condemning or demeaning to the student. But literally, my first statement after I tell them my brief testimony is I share with them how a camera failed me, how I missed a victim, and then how I was the reason that I caused the camera to fail because I didn't understand how the camera should be properly stored. And then I left it on a superheated surface, causing the batteries to discharge. So the first thing I tell them is how I failed, not how I've done all this stuff. No, tell them how I failed. And I think that opens them by being honest and vulnerable with them. And that stops a lot of that resistance, where if you stand up and beat your chest and say, look at me and how great I am, you're literally standing up on a podium and somebody's going to knock you off. I don't believe in being arrogant and boastful about stuff because we're all cut from the same cloth. So resistance, there's a reason to the resistance. I think it takes someone of understanding to see that and open them up.
I'm surprised it's not a standard tool as of yet. Is it not a standard tool? It's like a laptop, isn't it? You wouldn't go to work without a laptop.
Well, change is painfully slow in the fire service, but technology has moved at an astronomically fast pace, as you know. And I think what you're going to see is just like when breathing apparatus over where you are, they call them BAs, where here we call them SCBAs, were first resisted. Now the SCBAs or BAs are standard on every firefighter. Well, when they became standard, what was not standard on them was something known as a pass device. If a firefighter remained motionless, this device would go off and warn someone that a firefighter was down. Now every SCBA is required to have an integrated pass device. In my opinion, in the future, you will see some type of integrated thermal imaging or visualization for firefighters. That's not going to be the be all end all answer, but it's going to be part of the equation, because someone much smarter than me was quoted in a Firehouse article saying it is a sad state of affairs in the technology we have today, in the most industrialized nation in the world that we live in, that we still have firefighters getting lost in a smoke-filled environment. And I believe Dr. Grimwood says it, Paul Grimwood from your area there said, it will become a standardized thing in the future, that a tick on a firefighter will be like an air pack on their back or a fire truck in a fire station. But as I said, change is painfully slow. And I think funding and profit has a lot to do with it, because if you look at it, something as large as companies such as FLIR makes lots of cameras, but the fire service is this small as far as that percentage of sales. So when that becomes more of a market per se, when everyone has to have a camera, now that market opens up. And I think that's what's probably going to drive that change, is you get consensus standard change where things have to be mandatory, and you go from 100,000 firefighters carrying a camera to millions of firefighters carrying cameras. And I think that will help that change, because then there's more reason for manufacturers to jump on and get on that bandwagon. So it's going to be a combination of factors, I think.
How has thermal imaging technology changed the way you approach a firefighting operation?
From that day I told you the story where the gentleman pointed at the door and told me, what do you think now? It's completely changed my entire perspective. I looked at it as a one-sided equation. It's like assuming you know the answer to something and you haven't done your homework, and then you go in and jump in and you get upset at someone because you think you know what they did, and then you realize they didn't do that. It was actually your fault. You misunderstood it, and now you feel terrible. For me, I feel like the first 15 years of my fire service career, I was looking at the fire from the fact of looking at the building and looking at the smoke. I wasn't reading the heat and looking at thermal data. So I wrote an article several years ago on something called the thermal paradigm shift. And that's what happened to me. So I shifted my paradigm to look at it a little bit more openly. Not saying that I see everything, because we don't. But now I see thermal data and I know how important it is, because I study other industries that use it. And it's a multi-billion-dollar industry as far as what it's used for and how it saves money and saves lives and livelihoods and all the things that it does. But yet the fire service still hasn't caught on to that. So for me, when I began to understand the power of heat even from a qualitative perspective, it changed the way I fight fire, the way I search, the way I size things up, and more importantly, the way I watch over my people. I look at it and say, they've been in there too long. The heat's this much in the building. I'm moving over here, because what I understand about building construction and fire behavior and the data from the thermal imaging camera, it's made me smarter and faster and safer in that respect. Because when you get older, you want to be faster because you want to work, smarter, not harder. So it's helped me a lot. And I like what my father said about measuring and manage things. He was a Dr. Deming guy. And he basically said, if you can't measure it, you can't manage it. And I read an article from a thermographer who was a DOD guy, and he said that you can't mitigate a problem you can't see. You can't fix an issue that you don't know is there. Yes, we know there's fire. Yes, we know there's heat. We don't know where it is. We don't know the severity of it, and we don't know where it's going. We can predict with our training, our experience, but we can predict, and we can do that with our training experience, and we can be horrendously wrong, and people can die. And to me, to not include that data and to not have that training as an incident commander or company officer that's watching over someone is not only negligent, it's also very ignorant and arrogant to think that you don't need it. Because in the environment you work in, you need that tactical advantage because the fire is ahead of you from the moment the bell hits. So that for me, it's completely changed the way I look at it.
How do you integrate thermal imaging technology into your overall firefighting strategy?
That's a long, long answer. I would say the simple answer is we say that we didn't create, we call it, the word's been around a long time, tactical thermal imaging, which is, that's what we call our class, which is the use of thermal imaging to enhance strategies and tactics on the fireground, to make your service delivery better, faster, more efficient, and to detect unseen hazards that could harm the victim, the people you work with. So that's how I incorporate it, is simply knowing what I'm seeing, knowing my device, and I have to carry it. Believe it or not, the biggest obstacle you will overcome with incorporating it is getting firefighters to carry the darn thing. They leave it on the truck 50% of the time, per the last study we did with Firehouse Magazine. 50% of the time it's staying in the battery charger. I would argue that a cell phone stays off the charger more than it does on. So if we could get them to use them like cell phones, we might actually be able to do something. So for me, integration means it should be a part of a firefighter's personal protective equipment. It should be a part of their perspective when they look at something and realize the human eye only sees 0.3% of all light. So 99.7% of what's going on in the world around me, I can't see. And that camera sees 7 to 14 microns, which I cannot see. So why am I not carrying a device that could see things that could harm me, harm the victim, harm my people? Or if I saw them, I could fix the problem faster and make this problem go away and stop harm, reduce loss. That's the mission of the fire service. So for me, it's a no-brainer. It allows you to fix problems faster. And whatever you do, if you're married, don't teach your spouse to use one, because my wife now knows how to look at walls and say, that's not a load-bearing wall. When he goes on his next trip, I'm going to have somebody take this wall out. We're going to redo this. So she's taking it a little too far. So when you learn what these things can do, you can fix things, and you can also create more work for yourself as a spouse. So just be careful in that respect.
You defined it as tactical thermal imaging. Can you go into that a little bit?
Tactical is task related. Tactical is related to doing a task. Strategies and tactics, in my role as a battalion chief, I'm in the strategy world. I'm picking a strategy that I think is going to work on this particular incident, and the firefighters are executing that strategy through hands-on tasks. Tactical is the firefighters using it to do things such as size up. That's a hands-on task. Making entry and searching for victims. That's a task. Stretching a hose line and directing the stream and fighting the fire and fighting the heat. That's what we define as tactical thermal imaging. However, NIST defined it way back before I did. And you can look it up, and they actually define all of these different things you can use it for, from size up to checking upper layers for above your head for heat, for forensics, for arson investigation, for wildland firefighting. And everything they listed in that paper years ago is being used today. Now, the fire services, like you said, still resistant to it. But my mission is to change that. And my main mission is so that it benefits the citizen and benefits the firefighter and reduces a total loss of lives on both sides. So I think once that value is put into the fire service, and then I think a combination between litigation, consensus standard change and manufacturers coming on board, you will see it become more commonplace. But it's kind of like my daughter, who's 13, making her change. You have to make her change, and then she finally realizes she needs to do that. That's not an easy thing to do. So I would say, if you imagine in the United States, imagine 1.2 million 13-year-olds. That's how many firefighters there are, and we have to make them all change. And they like the way they do things, and you're going to change something. They're not going to be happy about it. So the first rule is come in and just add it, don't change it. Show them how it helps them do their job without changing their behavior. It changes the way they see it. The fundamental skill set is the same. The camera is just used to diagnose the problem. Before you force that door, I want you to look at that door and see if there's heat behind it. Before you stretch that hose down that hallway, I want you to see how much heat it is so you don't crawl under a superheated environment. I want you to flow water. So that's the tactic behind it. But that involves them literally doing something you probably do every day when you walk across the street. They need to look both ways and see what is out there that could harm me. Am I about to step out in front of a double-decker bus in London? Not a good idea. When you step into a burning building, are you about to step into a unidirectional flow path that's a full exhaust that after 30 seconds of heat energy absorption, you're going to be burned, injured, or killed? Probably not a good idea. But that requires them to stop, scan, communicate, and then go to work. That's that tactical side of it. Getting them to have incorporated in their PPE, to your other question earlier, is why is it not standardized? Getting them to look and then getting them to fix it. It's not as complicated as people would make it out to be. The level of research and knowledge behind it may be complicated, but putting it in what we call experientially relevant terms is not that complicated. So.
How does thermal imaging improve situational awareness and safety for firefighters and other first responders?
This one's personal for me. I've been lost and disoriented 3 times in my career, and I should be dead. No reason why. And two of which was being well trained in firefighting. I made a mistake, a big one. So for me to know that there is a secondary means of orientation, not a primary, that I have a way out if I get in trouble, why wouldn't I want to have it? Why wouldn't I want to use it? And then if you look past line of duty deaths and you look at just fire ground injuries, like I told you about my story about injuring myself and hurting my knee, I spent 6 months out of work. Every firefighter I know has at least 2 jobs, 2 occupations to make ends meet, because they're not paid that well. So now a firefighter is injured because they were lost or disoriented. They can't work their second job. They can't watch the kids or do the things for their spouse. 18% of all fire ground injuries from 2016 to 2019 out of 60,000 injuries that resulted in time off from work were due to firefighters becoming lost or disoriented. So having a device that improves situational awareness, and the master of this is Dr. Gasaway, not me. Look up situational awareness, look up samatters.com and look at what he's talking about. He talks about getting your brain to understand it, but now I have a device that allows me to improve that. Why wouldn't we do that? And why wouldn't we look at the research and stuff that's already been done, even though some of it's dated? Michael Whitty from Australia published in his paper that a firefighter who's properly trained and equipped with a thermal imaging camera, when they became lost or disoriented, found their way out of a building 100% of the time. 100% of the time. Do you want to go to bed at night without a smoke detector in your home? I don't. People don't wake up to smoke. Most people, they die. So to know that I have something that's going to see something that could help me find my crew and find my way out is phenomenally important. And the other aspect of this is too many firefighters just base their entire perception of the environment on what they see and what they feel. That's a late reactive measure. With the gear that we wear and the environment we're in, by the time you feel pain, by the time you see flame as a firefighter, it is too late. The fire has won and has got a tactical advantage on you. And we need to allow us to take back that advantage and gain ground on that enemy so we can get that victim out, save their home or their property. So for me to know that I have a device that can improve that, but we refuse to use it for whatever reasons, resistance to change, stubbornness, I don't like it, technology, whatever. None of that holds up in court, Karina. None of that. And I don't know about your world, but for some reason over here, they've decided that police, fire, and emergency medical professionals are the perfect people to sue now. And they figured that out. And they're suing them left and right for everything you can think of. So the last thing I want is to make a mistake that someone could say, well, this firefighter did not do his or her job, so we shall sue them. So why are we setting ourselves up for failure? We should be setting ourselves up for success, because every firefighter is issued equipment. And if they don't use it and get hurt, their organization is not going to back them. So now I have a piece of equipment that is issued to me that can make a difference, and I refuse to use it. How do you think that's going to work out for me? Litigation, injury, whatever it may be, it's not going to bode well in my favor, nor is it going to be when someone finds out that I could have used the device to save their children faster. So I think that's where we're getting to. I don't want to be made or make the fire service change due to litigation and spurring that. But thermal data is important to every industry out there except ours. And the research shows it is, but yet the research itself doesn't include modern updated cameras. So I think we've got a little ways to go.
I can't believe that 100% of the time they managed to get out.
And that was done by Michael Whitty in 2008. You can look up the paper if someone wants to. Everyone always asks, where'd you get the data from? Fine. Maximizing Thermal Imaging Use in Emergency Services by Michael Whitty. Phenomenal 40-page short research paper. Best research paper I've written, because it was written by a firefighter, so any firefighter can understand it. Very straightforward, to the point, quotes where he got the information from. He wrote the paper due to a loss of a loved one in a fire. He dedicated that at the beginning of the paper. So it gets your attention right off the bat. But yes, it is very profoundly important that firefighters understand that. And you're not over relying on the device, simply no more than you would rely on your cell phone to give you directions when you need it. I am just amazed or appalled at the hypocrisy of firefighters when they say, I don't want to over rely on technology, but they'll sit in a room full of firefighters and they won't talk to each other, and they're texting each other. And they're looking, you're not even talking to each other, and you're using technology to do it, but yet you won't use it in there where you could die. I said this recently. I said, this device, a cell phone, can cost you your relationships, your marriage, and a lot of things if you're playing with this thing. But a thermal imaging camera that costs about the same as an iPhone or Android now can save your life if you don't want to spend it or use it on that. That's a problem.
So without the camera, previously firefighters were just relying on feel and to get their way out of situations.
Visual cues and training, yes.
Wow.
Yeah, basically, and that's very difficult if you've been in an environment where you're completely disoriented. And firefighters do train on that, but are they trained enough to know that when they're panicking to do the right thing? A friend of mine who had, one of my guys actually, who had a Mayday, he was directing a crew out of the building when the fire conditions changed. And his exact words were to me, I just wasn't ready. He said, the amount of energy that hit my face grazed his mask over, where even with the thermal imaging camera in his hand, he couldn't see it because his mask grazed over and melted. He said the pain was so intense that it overwhelmed him. And the only thing he could remember to do was put his hand on the wall and find that window, and he pushed the board out and jumped out the window. So I don't think firefighters really understand the levels that their body will be pushed to when that event happens, and what level they'll fail to. And if they read about these guys and gals who died in a fire, they didn't behave like perfectly calm, competent. Some of them ran towards the fire. Some of them took their gear off, folded it, sat in the corner and sat down and died. They did some really unusual things due to the things they were breathing and what was happening to their body. So why wouldn't I want to have an advantage to say, okay, I know I'm in trouble, but I'm not that in trouble yet. And I can see my way out. I can find the hose line, find my crew, and get out safely, or find someone who needs me to get them out safely, more importantly.
I think it's interesting that you said that when his mask went over, he did end up not relying, but he went back to the primary training that he was given, because you're not saying to remove that training, just saying it's an added layer.
Best that what we teach is a force multiplier. So in order for you to, have a skill set to multiply, you have to have a skill set first. So if my skill set is 0, 10 times 0 is 0. That means I'm not a good firefighter.
Mhm.
So this individual I'm talking about, one of my guys, he had a very good skill set and he fell back on that skill set. And I think
Mhm.
between that and the grace of God got him out, because it had been anybody else without that skill set, I think he would have died.
Mhm.
But people don't realize that you fail to your base level. If you think about your home right now, envision this in your mind. You're asleep in your home in the middle of the night, and you have a fire. What door are you going to run to? Which one?
One that's not on fire. I've been in a fire
Well,
in the
well,
house.
God bless you, because
Yeah. I just
everyone,
listened to what my dad said, to be honest. I
well,
think I blanked out
most
to
people run towards the
the adult.
door they
Mm.
always use.
Mhm.
So if you look at these terrible incidents that are going around the world, from riots to active shooter or whatever, if they're in a big building and shots are fired, people run back the door they came in. They don't
Mhm.
look for the exit door to the side that's right next to them. My
Mhm.
wife and I joke that if there's a fire in our home, we're going to run to the opposite end of the house to get our daughter. Then we're going
Mhm.
to run to the front door to get her out when there is a door 6 feet from my daughter's bedroom. But we don't
Mhm.
use that door very.
Mhm.
So when I say you fail to your base level, my instructor, he failed to his base level, which was training. That's what thermal imaging can do for you. If you needed it prior to that, he still had his fundamentals. But the thermal imaging could get you out or help you do those things. But your batteries, if you will, are your fundamentals. The thermal imaging camera batteries may die. It may quit due to technology. Everything with technology, and it will fail at some point. But people have to understand that the device can enhance your fundamentals. It can be a force multiplier, but it can't do any of that if A, you're not skilled, and B, you don't carry the darn thing.
Mhm.
So that's where we're at with it, is we can't be resistant to technology. No different than a friend of mine sent me an article from a paper years ago where horse-drawn fire steam engines versus motorized fire engines were first introduced, and the firefighters did not want the motorized fire engine. They wanted to keep the horses. That's how obstinate and resistant we are to change.
Mhm.
Think about that. So,
Can you remember a specific firefighting scenario where thermal imaging was critical to the operation's success?
I would say several, but for
Mhm.
myself and the guys that work for me and many people we've taught, they talk about two things happening on a regular basis, and I've experienced it myself. Is using it from the size up perspective when you're walking around the building to determine where the fire is, where it's going, where are potential spaces people could be trapped, and then that initial look through that front door before I make entry and gain that information about the layout of the building, the fire location, and where that victim is. Those 2 points using that camera is probably the most valuable thing we teach, because once you make entry into that environment, you're not promised what kind of visibility you're going to get. You don't know what kind of conditions you have. You could have light smoke. You could have optically dense smoke that could obscure your vision, which prevents you from even seeing the camera. You could have high moisture content smoke, which thermal imaging cameras hate moisture. So that initial walk around, or 360, if you will, with the camera, and then being able to make that initial look, and that what we call our size up or tactical 360, has been the most beneficial thing for me, because I've been able to find the fire and figure out where it's, the acronym in the States we call BAG. Where's it been? Where's it at? And where's it going? And then I can see things that a lot of people miss. I have a video of where we had a house fire, and I noticed the company officer went around his 360 but never looked at it with his camera. And I asked him why he was frustrated. He said, I couldn't find the stairs in the building. I had to push through fire to go around the back to make the stairs. And I said, come over here with me. And we stood on the side of the house that was completely sided, vinyl sided, no windows or doors. And we picked up his camera and we looked at it, and you could see the riser treads of the stairs going up the side of the building through the wall. It's not X-ray vision. It was a temperature differential, thermal bridging between where the studs touched the wall and the exterior space and the temperature difference. The camera picked it up, and he just put his head down. I was like, hey, we learned. Not your fault. The department's not pushing it. I'm helping you now. Use it in the future. So to me, the size up and that initial look with that device, if firefighters would do that, it would change everything for them, whether they used it or not from that point on, because at least they know where the fire is, where they start their search, where they're stretching their hose line to, and they have what we usually don't have, which is a pre-plan. I have an idea of how this building is laid out and the conditions within it, which we usually don't get that luxury. So now I have an advantage I don't like going to war against something and being at a disadvantage. So
What's the biggest misconception people have about thermal imaging in firefighting, and how do you correct it?
I would say a couple of different things. For me, when I first started teaching, I was told, don't use the spot temperature, don't use the spot temperature, it's inaccurate. And for some reason, when we were first teaching it, people thought we were telling them to use the spot temperature. And then further from the truth, they'd hear a number and they thought we were referring to that number. We look at apparent temperatures, which is what the camera gives you. Using the spot temperature and in a thermal imaging camera for a firefighter, probably the most dangerous thing you could do. And it took a long time for NFPA to realize it shouldn't be there. They took it off on the new NFPA 1801 2021 standard. When you turn it on in TI Basic, the number's not even there on the bottom right-hand corner. Because firefighters will look at that number and they think it was indicative of the entire environment. So that's dangerous, number one. Number two, it's not a thermometer. It can be several hundred degrees off. It's not a quantitative industrial camera. It doesn't have the ability to adjust for variables such as focus, range, distance, emissivity, atmospheric attenuation, reflected apparent temperature. You don't have an anemometer when you go down the hallway to see what the wind speed is and the ambient temperature of the room and program them all into a camera. Firefighters don't have time nor the luxury of doing that. We have a qualitative device that gives us that layout and gives us an idea of those conditions. So to this day, there are firefighters still using that spot temperature measurement, not knowing that the reason they took that number away in the new standard was it was cited as a contributing factor in 3 line of duty deaths. And there are departments that have it in their department standard operating guidelines that the captain shall give a temperature report over the radio, a number. And this listed in a line of duty death report in the United States where the captain did that, and they're dead. And that's sad because the fire service should be held liable for that. And thermographers, manufacturers have all said, do not use the temperature indicator for critical decision making. It is a apparent temperature or uncompensated temperature measurement. We've taught that from day one, or somehow, some way, firefighters hear something and they misinterpret things. And we have done our best to push and say, we want you to see the heat. Don't focus on the exact measurements. Industrial thermographers deal in tens of degrees. Firefighters deal in hundreds of degrees, if not greater. And we don't want them to mess that up. I'd say that's probably the biggest issue. When we do our classroom hybrid, we use a product called the Max Firebox, and it basically burns inside the box, but the side of it is diamond plating like you see on American fire trucks. Not so much overseas, you'll have the diamond plating. Y'all have much prettier colors. But the box is very shiny, which is a low emissivity object. So when the box is blowing flames out of the side of it, we have them stand and look at the diamond plating and read the spot temperature on the thermal imaging camera. And it will say it's close to the ambient temperature outside. And when I always ask them, I take my glove off and say, any volunteers who want to put their hand on the side of this box? Nobody volunteers to do it because the box is very, very hot, but emissivity, as we know, is the single most important attribute in temperature measurement. And a fire service camera is not adjustable. If I could adjust it, I could see that that box was very hot. But that camera is set at 0.95 to 0.97 emissivity, which is what most carbonaceous objects are on this earth: human skin, rough surfaces, wood, soot, things of that nature. It's not a shiny surface. So you can teach firefighters textbook definitions like emissivity is the ability of an object to emit, absorb, reflect heat numerically between 0 and 1, and they're going to look at you and roll their eyes. Or you can say it's shiny, it'll burn your hiney, don't touch it. And if it's rough, you can trust it. But we have to find this middle ground where we're not teaching theory and thermography as much as we are giving them examples of why this camera can hurt you if you don't understand it.
Yeah, I just finished my level 1 and that's what we got taught: low emissivity lies.
Well, I am amazed. I'm shocked and amazed that I'm talking to somebody who's got a level 1 who's in marketing. So you do a much better job than anybody else I know. So that's good.
Yeah, it's good. FLIR sends us all to so we have a basic understanding.
If you spent 3 hours on emissivity in level 1, you have more than a basic understanding. You have a migraine and you can say the word.
What's the most unexpected way you've used thermal imaging cameras on a firefighting call?
I'd say several. Basically identifying hazards I was told I can't see, like walking back to my car as a battalion chief when there was a hazardous material incident where the cable company had cut a 2-inch commercial gas line underground. It was 3 feet underground, but they had these orange pipes where they run the cable line through it, sticking out of the ground. It's a 100-degree day, like a 45 to 50 degrees Celsius day, very hot. And the ground is showing on the camera around 100 degrees. But right where that pipe's coming out of the ground is this dark V pattern. And I thought to myself, if I can't see gases with a fire service tick, which it cannot, it picks up surface temperatures and the changes coming off of it, why am I picking that up? And the gas coming from the natural gas coming from the LP or petroleum company was at 58 degrees Fahrenheit, very, very cool. And the ground was very, very hot, and the gas was cooling the surfaces, and the camera was simply picking it up. To seeing something like, if you've been in these bars where they have carbon dioxide tanks in the back for the beer places or the soda machines, we saw one that was leaking, and the wall behind the tank had a beautiful dark pattern where the CO2 gases were cooling the wall, allowing us to find the tank that was leaking. We saw a down power line on the street that was not visible with the naked eye, that lit up on a camera that was around 7,200 volts that would have killed him. A homeowner called 911 after a hurricane. He had no power to his house and said, my water is coming out of my faucet so hot, it's burning my hands. His next door neighbor was using a generator, which backfed the electricity to his house, went through an open ground, which was done improperly in his house, and energized the gas line to his hot water heater. They took your camera, a K65, and pointed it at the hot water heater, and that metal gas line lit up between 900 and 1200 degrees Fahrenheit. That's a bad day to find that out with your bare hands. So those are some of the most unusual things I've seen. There's several, but to me, I have pictures of those because I show them to firefighters. It's not just the fire ground. There are so many other ways you can use it.
When purchasing a thermal imaging camera, what are the most important features that you look for?
Well, remember what you asked me in the beginning? Why are firefighters resistant to change? What do you think they're going to do when you hand them a device that has 5 buttons, lots of icons, and complicated color palettes? They're going to put it away. And then in the environment they work in, which is very stressful, very hard to see, I need something that's simple, fast, and provides the best image clarity in the worst condition. And for me, that's the first thing. And then secondarily, I would want something that has an investigative feature. Like if you talk about a FLIR product, it has a search and rescue mode on your KXX series cameras, which is my favorite application feature because it highlights color early, allowing me to see a problem when I'm further away versus close to it. A friend of mine that used to work with FLIR, Mike Chapman, who taught me a lot, said you use that application mode early or late. That's probably the most profound way of explaining it, because when you're far away and looking at it, you're not going to pick up a temperature at 300 or 400 degrees far away because the energy is dissipating. So it highlights that problem early. So that, to me, having speed, simplicity, clarity, and having an investigative feature in a high resolution camera that doesn't delay information, that's probably the biggest thing. Is these cameras that are slower are causing firefighters problems. That's
How
what
sorry.
That's all right.
How exactly does the search and rescue mode work?
Well, if you have that particular model, there's 5 application modes. My favorite is the TI basic and then search and rescue mode. I program mine where I only have those 2 options, so it's very difficult to mess up. I have option 1, option 2. But search and rescue mode, instead of having a dual gain or high and low sensitivity camera, you have a single gain. You have a 0 to 300 degrees Fahrenheit or 0 to 150 degrees Celsius total temperature span or range. It's all it's looking at. But it highlights color early, where in TI Basic in the FLIR series, it highlights it at 302 degrees Fahrenheit or 150 degrees Celsius. Whereas in Search and Rescue, it highlights it at 200 degrees Fahrenheit or approximately 100 degrees or a little under 100 degrees Celsius. I'm doing firefighter math, so my friends overseas, don't shoot me if I got the Celsius equation wrong, okay? I know we're crazy because we still use Fahrenheit and feet. We should all go with metric system. You'll yell at me enough. I can't get this country to change. I'm trying to get them to carry cameras. You think I'm going to get them changed to Celsius? Not happening. not in my lifetime. But to me, search and rescue is investigative mode. I like cameras that have, and I'll go back to that research paper I quoted you. Michael Whitty's paper said a fire service camera should have two application modes, fire and investigative. And I could not agree with that more. Because one, you have seconds. You come off a truck, people are screaming, you turn on camera on, you don't have time to press buttons. You need a camera to work. But when the seconds and the stress are off, and you are looking for an overheated electrical component, or you have light smoke and you can't find the fire, an investigative tool such as search and rescue mode in your camera is very beneficial, because despite what the movies told you, they lied. There's more than 50 shades of gray. Your fire service camera has 255 contrasting shades of gray Crayola crayons on that screen. And you will enjoy this part. The average female can see 30 shades of gray. The average male can only see 10. This is why I'm not allowed to pick out colors when we go pick out paint colors and furniture. So, but if a man and a woman are both on a hose line fighting a fire under stress, they can only see 4 shades of gray. So early colorization in a stressful environment is a game changer and helps firefighters make decisions better. It's a balance. It should not be too much color or too little. But if you read NFPA, it says TI basic shall be no more than 50% of the overall temperature range span shall be grayscale. So if I had a 1200 degree range, then 600 of it can be up to, black, gray, white. I like it to show up earlier, because if you do your homework in our world, especially where you are, the word IKEA rings a bell, I'm sure. Their furniture is made of glue, sawdust, and petroleum products. And when it starts heating up at a much lower temperature than solid wood, it starts producing flammable vapors. Wouldn't you want to see that before it lights on fire? And I think an early investigative mode, such as search and rescue, or there's lots of manufacturers that offer them, is very beneficial to firefighters, but it doesn't do any good unless they have training. That's why if you read something as simple as NFPA 1408, which is the thermal imaging training standard, it says firefighters shall have training on these devices before they go into an IDLH environment, immediately dangerous to life and health. Or to quote Aaron Fields, IDLH stands for I don't like heat. You're not want to go in there without having training on this device. So that particular application mode is very beneficial.
Great. So FLIR is celebrating its 10-year anniversary of entering the firefighting market with its thermal imaging cameras in 2013. Please talk us through your first encounters with FLIR thermal imaging cameras and our collaboration over the years.
I've seen them before I started working with you, but I did not have a formal experience with them until I met Jason Messerschmidt in 2016, and it gave me an opportunity to evaluate the K65 at the time. And that's where I got introduced to it and started using the KXX series products then, and became very intimately familiar with all the lineup from K1 to the K65. And now I'm learning about other FLIR products as well, because I do a lot of other things industrial and inspection wise that I'm learning about. But the KXX series lineup from that point introduced something called FSX, which is flexible scene enhancement, which was a benefit because it added extra detail and the upper temperature range, which gave firefighters more situational awareness. So I particularly like that. And I worked closely with FLIR for several years and learned those cameras. I'd say, like I said before, that and the search and rescue mode was a very beneficial feature. I wish manufacturers would spend more time on choosing which features they add. I'm not a big fan of lots of extra buttons, because when a firefighter's heart rate is over 170 beats per minute, they can't push buttons anyway. They can't even tell you their street address when they get what they call condition black. And if you read about the stress response to the human body, you want a camera that can do one or two things really well without a lot of complicated bells and whistles. So I particularly like those two features of it, the FSX in the TI basic and the search and rescue mode. As far as that particular one is the one that I enjoy the most out of.
What does FSX do?
Flexible scene enhancement is basically, if you've ever played with Photoshop or image enhancement, it takes a standard infrared image and through software, it adds detail to the background. So if you look at it and you look at FLIR's picture prior to FSX and then afterwards, it's an infrared image with black, gray, white, yellow, orange, red. with very little detail within the colorization or colorized areas. Where when they've added FSX, you can see where that color is, and anything in there that's superheated. There's a chair, a table, a wall, a window, door frames, it outlines it. It's almost as if there's manufacturers using things called edge detection. It's very similar, if that's without getting into proprietary stuff, how that works. But it outlines that and picks up those heat signatures around that and gives you almost like if you've taken a piece of tracing paper and laid it over something and you traced it, it's tracing those edges, giving that firefighter more situational awareness, such as you crawl into a bedroom that's on fire, the mattress is burning, the flames are to the ceiling, but behind the flames is a doorway to a bathroom with a child hiding in it with the door shut. Most thermal imaging cameras, if you have a lot of flames and heat right there, the door will not be visible behind that. NFPA says that details shall be resolvable within colorization up to the point of saturation. So that means they have to, every manufacturer who has an NFPA certified camera has to show detail behind the color up to the maximum temperature range. So once they hit 1100, 1200 degrees, they're allowed to completely block out that detail. The FSX doesn't do that. It outlines it all the way up to its max temperature range. So it gives that firefighter more detail in bad situations and allow them to say, hey, that's a doorway. Or what I'd like to say is if I look into a room and it's a big open, great room and it's a long table, instead of saying, I think that's a table, with FSX, like I say, that's a table, 3 chairs, 2 high chairs, and a wheelchair. That tells me a lot about who I'm looking for in that environment. So that's where you're seeing manufacturers going, is starting to add more of those software enhancements. The infrared camera industry is kind of, in my opinion, dialed out on using 320 by 240 cameras. They need to upgrade them, and what you're seeing is software enhancements is the way to do that. So that is a particularly interesting software enhancement.
What has been the greatest development in the fire industry over the past 5 to 10 years?
For me, actually, it hasn't been thermal imaging. It's been the research and the data that points you to why thermal imaging should be important. Because as you said earlier about the resistance to it, what makes people change? If someone tells me I need to eat right and exercise, I know that in my heart and my head. But then when you're 31 years, let's see, I'm 47. So I was 34 when my daughter was born. And I'm holding a perfectly healthy baby girl. And I'm overweight, out of shape, and my wife's hemorrhaging in the next room from her C-section.
Oh my God.
What makes you change? Love, tragedy, data that means something to you. I changed my lifestyle from that point forward completely. I'm not perfect by any means, but I ran 3 marathons since then, and I still work out, and I try to keep up with these young people I work with. They try to kill me, but that made me change. And the most innovative thing that I've seen is changing firefighters' thinking by giving them more data on why this has to be done. Not just convincing data, condemning, compelling, heart-wrenching data. Whether it's a victim, whether it's the firefighter's line of duty death, whether it's how many people we're saving through firefighter rescue survey through Brian Brush and his work, average of over 10 Americans per day are being rescued from homes. Then you say, well, if we add this can help us rescue victims faster, rescue more victims. We can save this homeowner's business, and we can do these things and potentially save firefighters' lives. You start in the heart, then you hit them in the head, and then you hit the people who buy it in the wallet. That's the 3 points I teach from. And why I told you that is, where did I start? With my daughter. That big change for me was, I don't deserve this. I've got to fix my life. People have to realize these changes we're seeing around us, some of them are being made to change, and some of them are realizing this is the way. And I think we're going to see more of them say this is the way, and then you're going to have the people that are just made to change. But I think the research from places like UL Fire Research Safety Institute, Illinois Fire Service Institute, from my dad's project, Killed Flashover, and lots of many other great places, and hopefully some of the work that we've done by just simply, we're not researching as much as we are taking the information that's there and we are sharing it to firefighters. Do you think the average firefighter is going to sit down and read 4 700-page research papers? They're not. especially they're married and work 2 jobs, but we do. And then we turn around and share bits and pieces of it, pointing them to, here's the QR code. We don't even type the link in the presentation. We put a QR code, say, get out your cell phone, scan it, you go right to page 26 and you can read it.
Mm-hmm.
So they can physically see, I need to do this. I need to understand this. I will be able to get home to my family. I will be able to protect the people I work with. That's where I've seen the biggest change, is not the technology, it's the thinking. Because you can, David Eskew taught me this, innovation without education leads to frustration.
Mm-hmm.
You cannot have an innovative product and an uneducated user. You will fail. And that is where the thermal imaging industry has failed. And we have been trying to change that. You want to make innovative products, you better have a way of convincing your consumer why they need it. And if you don't, it'd be the best thing ever made. It'll sit on a shelf and it'll just collect dust. And I think people are finally starting to wrap their head around the fact that this is important, but now they know why, because there's enough information saturating the channels of social media, which is what everybody reads, to realize that this data produces a difference in people's lives, and their property, and in the fire service.
I think the fire industry is very lucky to have you.
I don't know about that, but I'm a necessary aggravation.
Yeah.
Some people think that, some people don't.
If people would like to learn more about Insight Fire Training, how can they get in touch?
Well, they can get in touch with me, or they can get in touch with my 13 other people that work with me. I'm very blessed to have a lot of instructors now that are very passionate about it. You can go to my website, insighttrainingllc.com, and hit the contact us page, which is the easiest thing to do. You can go to our Facebook page, Insight Training LLC, or you can go to my other lead instructors' Facebook pages, Instructor Thomas Anderson, Instructor Joey Baxa, Instructor Tim Mills. You can go to LinkedIn and find me, or Insight Training. You can go to Twitter and find us. You can go to Instagram, and you can even find me on TikTok, which I don't go on there very much because I'm not a big fan of it, but I have one. And then you can even email me at andystarnes@instructorandystarnes.com. And on my Facebook page, it has my cell phone number. Don't call me after 10 p.m. My wife will shoot me. That is the basic ways, but we post something on social media every single day for the last 9 years. And if you go under Google and type in tactical thermal imaging, watch what pops up. We don't pay for search engine optimization. We have saturated it with articles and posts and videos. Our YouTube channel has 700 videos organized by brand, subject matter, and I got a lot more coming. I got 4 little hard drives over here, external hard drives. There's 8 terabytes of stuff just from January of us filming. So we have a lot of things to share. It's just whether or not I can make time and get enough people to help edit video and put it out there. But we provide free resources on our website, and we have a private Facebook page where firefighters can answer questions, get files for free called Tactical Thermal Imaging. You got to Google it on Facebook's little search thing. And when it says join, you have to answer 2 questions to prove to me you're not a spammer or a robot or whatever. I don't put up with political or workout stuff that you're putting on there. It's thermal imaging and first responders. That's it. And it's there. There's about 9,000 members in it. There's manufacturers in it. And they all behave, believe it or not. They're there to help the firefighter. So I'm very happy with that. And as long as we continue to share information and not knowledge hoard, I think we're going to be a better place in the next few years.
Thank you. Thank you so much for your time.
Thank you for the opportunity.
Thank you very much.